All right, good morning. Today, your first lesson is on classifying real numbers. So we're going to learn a whole lot of information just about real numbers. So first of all, numbers are split into real numbers and imaginary numbers. And I know you all looked at imaginary numbers in Algebra 2, and eventually we will look at them some here in Algebra 3, but we're primarily going to concentrate on real numbers. So real number is just any number that's not imaginary. And then if you remember, probably way back to algebra, or maybe even pre-algebra, real numbers are split into irrational and rational numbers. So the easiest way to remember the difference between those two is real numbers can be written as fractions and irrational numbers cannot be, okay? So even if it's a decimal, you say, hey, can this decimal be written as a fraction? And if it can, it's a rational number. If it's not, so an example of irrational would be pi, because pi goes on forever and ever, and there's no way we can write that as a fraction. Now, you may have been told before that you can estimate pi with a fraction, I believe 22/7, but that's not an actual value for pi. It's just an estimate, okay? Rational numbers can then be broken down into integers and non-integer fractions. Remember, integers are positive and negative whole numbers, okay? And then we can break integers down specifically into negative integers, which is just a number less than 0. And then the last two, well, I guess 3, would be whole numbers and natural numbers. So whole numbers and natural numbers are the same set of numbers except for one value. Whole numbers include 0, and they go in the positive direction to infinity, but natural numbers start at 1 and go to the positive direction towards positive infinity, okay? So I remember that whole numbers start with 0, because it has an O in the word whole. Okay, so whole starts with 0, natural does not. And then we just have our number 0. So we are going to create our number line. Now, please bear with me today. My iPad's at school, so I only have my MacBook to draw on. So we have 0 in the middle that's called the origin, and you want to label that as origin. And then down here, we have positive. Told you this is going to take a while. Positive numbers, I'm just going to put positive infinity. And down here, I'm going to put negative infinity. Okay. And then we have all of our positive numbers, and you can label a couple here if you'd like to. And just know that they keep going. So that's positive 1, positive 2, positive 3, so on and so forth. You can label a couple back here. Hopefully yours looks better than mine. Negative 1, negative 2, negative 3, and so on. Okay. So I'll give you a second to get caught up there. All right, and now we're going to look at inequality symbols. Okay, so inequality symbols, remember there are 4 of them. So here we have greater than. Okay, and I'm going to ask that you please, let me see if I can. Okay, so write out the word greater than. Then we also have less than. Again, please write those out. Here we have greater than or equal to. And then here we have less than or equal to. Right, so there's our 4 inequality symbols because we're going to look at those on a number line. And typically we would use this type of notation, but today we're going to go back and forth between inequality notation and interval notation. So interval notation looks something like this, where we have brackets and parentheses. Okay, so I'm going to show you what the inequality looks like, and then we'll go from there. The other thing I want to refresh our memory on is what these mean. So greater than and less than were open circles, okay? So remember, open circles on the number line where we're not including those numbers. But we don't want to move to the next number because then we're going to be missing all the decimals and fractions inside of there, okay? The less than or equal to or greater than or equal to, those are closed circles, meaning we are counting those numbers. Okay, so we have a nice shaded in circle there. Perfect circle. And then an open circle there. Looks like a zero. Excuse me. All right, so if A and B were our numbers, and to make this easier, because I know every year students struggle with this, I'm going to say, instead of A and B, that way we have numbers, we'll do like -2 to 3. Okay, and this is a closed interval because both sides have brackets. So the way I tell students to remember this is think of like a half pipe, whether you're skateboarding or snowboarding. A half pipe is sort of open, and a half pipe to me reminds me of parentheses, because the parentheses I'm able to get out. Like we can go back and forth in the half pipe, and then when you're done, you can just sort of go off the edge and off to the side. However, if we were to build like a little wall there on this half pipe, let's see if I can zoom in here. So we are going to get stuck right there. So we are closed in on the half pipe if they were to put little walls there. I wouldn't be able to fly out and around. So that's sort of how I remember which one is closed, which one is open. So to graph this interval, I would have my number line. And I'm putting it in the wrong spot. All right, so let's graph it, and then I'll write the inequality. So a closed interval. Now all I need to really do is put the values I need here. So I'm going to do -2. And then I'm going to put +3 up here. I'm going to put 0. Notice how I didn't put 0 quite in the middle. I put it closer to the -2. So now let's get a different color. I have a closed circle here and a closed circle here. And I have all the numbers in the middle. Okay. What that inequality would look like, it would be, okay, I have x, which is all my real numbers, less than or equal to 3, because remember 3 is the maximum value, and it's the bracket, so it's the close, which means it has the equal to, but x is going to be greater than or equal to -2. And we wrote that as a compound inequality. Could also be written as a regular inequality. All right, so I'm not going to graph the others, but we will write the inequalities for them. So the open, I will use the values -2 and 3 again. So it would be -2 less than x less than 3. Okay, so that's if we're doing -2, 3. All right, and that is considered to be completely open. That's an open interval because both sides have open circles. Now the last two don't have an interval type because one side is bounded, the other side is not. So if we were, say, bounded at -2 or closed at -2, 3, it would be -2 less than or equal to x, which is less than 3. And then the other one would be -2. Now it would be less than x, less than or equal to 3. Okay, so you guys can try graphing them. The graphs will all look very similar, except this one here will have an open circle, shaded in the middle. This one will have closed circle, open circle, shaded in the middle. This one will have open circle, closed circle, and shaded in the middle. Okay. So if we have bounded intervals, we also have unbounded intervals. So unbounded intervals meaning we are going to infinity in one direction. For this example, we'll just use, again, a is -2. I'll write that up here. A will represent -2, just because it's easier sometimes to have values instead of a whole bunch of letters. And B will say is our +3. So if you think back to inequalities that you wrote in algebra, we didn't always have like x is greater than 3 and, or sorry, x is less than 3 and x is greater than -2. Sometimes you just want to say, hey, x is greater than -2. And that's okay. And that's actually what this first one means. So if I just have an infinity, I'm going to have just one inequality. Okay, and if it's going to positive infinity, that means it needs to be greater than. And in this case, because I have that bracket there, it's going to be greater than or equal to, and a is -2. So if you remember this graph, I would have my -2 here. And we'll put our 0 there. So I have a closed circle at -2 and everything shaded to the right now. Okay, because it's going to keep going towards infinity. All right, the next one. This is just going to be x is greater than -2. So this would look exactly the same, but an open circle at -2 and shaded to the right. The next one will be x, because now it's towards negative infinity. So it's going to be less than or equal to 3. Remember, I see this bracket right here that tells me it is going to be equal to. And since I'm going from b to the left, because negative infinity, that's what it would look like. So now this will have 3 here, 0 there, a closed circle, and everything shaded this way. Okay, next one, similar, whoops, except it's going to be x less than 3. Again, the graph, open circle at 3, shaded to the left. And finally, the last one is just all real numbers. Okay, we don't typically write, but we will do this here. Now, we don't put equal to infinity because it can never be equal to infinity. And this would just be your whole entire number line shaded. Okay, so the entire real number line. All right, so now we are going to move on to our first example. As you see, we only have 2 examples today, and this type of stuff you guys have done before, especially for inequality notation. We're just going to go through a little review. So it says use inequality notation to describe each of the following. So C is at most 2. So that means 2 is the biggest number and C is at most 2. So that means C, oops, go back to my draw. C has to be less than, it says at most 2, which means it can also be equal to. So C is less than or equal to 2. We are going to write both inequality and off to the side, I'm going to write interval notation because I know your practice work asks for both. So less than or equal to 2, so that means bracket, parenthesis. And if you notice, anytime I have infinity, I have to have a parenthesis because it cannot be equal to infinity. And we are including 2, so that's a bracket. Okay. M is at least -3, at least, which means it can be -3, but it's also going to be greater than -3. So M is greater than or equal to -3. So if we are doing interval notation, that will be bracket at -3. And we are going all the way to positive infinity. Okay. Now the next one says all x in the interval -3 to 5, including 5. So this right here, since I have 2 values, my x is going to be in the middle. It's going to be less than or equal to 5 because 5 has the bracket. -3 just as a parenthesis, so that's -3 there. Okay. And we're all done. So pause the video, take a second, try these next 3, and then come back and work on those. One thing I forgot is I forgot the negative up there with the infinity. All right, so hopefully you got all of those right. Let's move on to example 2. Now it says give a verbal description. So I'm going to say, just delete this. All real numbers between -1 and 0. Because we are counting all of those numbers, but we are not including -1 or 0. The next one, if we were to do this one, we would say all real numbers greater than and equal to 2. I guess technically I should have wrote these out. And finally, C, all real numbers less than 0. Right, so again, pause the video, take a second, try these 3 your turns, and then come back and see if I'm correct. All right, so hopefully you got to check those and you're good to go. All right, last little thing we have to go through is absolute value and then distance. So absolute value is the positive distance between the origin and any point on the number line. Okay, so we know that the absolute value of +5 is +5. The absolute value of -10 is +10 because distance can only be positive, which is why we're looking at distance here. So what this is saying, to find the distance between any 2 numbers on a regular number line, you just subtract those 2 numbers, but you take the positive value. So the order in which you subtract doesn't necessarily make a difference. You just need to remember that you subtract them, but you always take the positive value. All right, so if you have any questions when you work through your practice work, don't hesitate to send me a message on Remind. Have a great day, guys.